Formula of simple ionic compounds. Hi there class. Today we shall be learning a new topic, but before that, let's do a quick recap. Let's recap on the concept of valence electrons and group number. As you may know, the valence shell of an atom refers to the outermost electron shell of the atom. And the valence electrons are the electrons that occupy this valence shell. For example, let's look at magnesium. If you look at the numbers on the periodic table, you see 12 and 24. And if I ask you, what is the electronic configuration? Which number will you look at? Okay, yes, you look at the smaller number. Okay, because the smaller number corresponds to the number of protons. And in an atom, the number of protons is equal to the number of electrons. So if I have 12 electrons, how do I arrange them in the shells? How many electrons can the first shell take? Think about it. Yes, okay, the first shell can only take 2. Now I have 10 electrons left. Can I put all 10 electrons in the second shell? Okay, no, you cannot, because the second shell can only have a maximum of 8 electrons. Okay, now I already have 10 total electrons. So how many electrons will be in the third shell? 2. Right, so if you draw it out, this is what it will look like. The first shell having 2 electrons, the second shell having 8, and the third shell having 2. And in this case, the third shell is known as the valence shell. And there is 2 valence electrons because there are 2 electrons in the outermost electron shell. And since there are 2 valence electrons, which group will magnesium be inside the periodic table? Okay, since there are 2 valence electrons, magnesium will be in group 2 of the periodic table. Please remember, the number of valence electrons corresponds to the group number. Alright, another recap, the stable noble gas electronic configuration. Noble gases are stable because of fully filled valence shell. Right, let's see examples of 3 noble gases. Okay, we have helium, neon, and argon. Okay, they are in group 0 of the periodic table. Okay, helium, if you look at the proton number, it has 2 valence electrons, it has 2 electrons total, and therefore the electronic configuration would be 2. And because it has 2 valence electrons in its outermost shell, okay, we call it a duplet configuration. For neon, okay, there are 10 electrons total. So how do we arrange 10 electrons? Okay, that would be 2, 8. And since the valence shell has 8 electrons, or we have 8 valence electrons, we call that a octet configuration. Okay, moving on to argon, 18 electrons total. How do we arrange it? We will get 2, 8, 8. And once again, since there are 8 valence electrons, this is known as the octet configuration. So, noble gases are stable because their valence shells are fully filled. Next, how are ions formed? Okay, atoms gain or lose valence electrons when they react in order to achieve a stable noble gas electronic configuration. For example, let's look at magnesium. As discussed, the electronic configuration of magnesium is 282. Alright, for the atom to be stable, it can either become 288 by gaining 6 electrons, or it can become 28 by losing 2 electrons. Okay, because it wants to achieve a stable noble gas electronic configuration. It wants to have its valence shell to be fully filled. So class, think about it. Which one do you think is easier? Gaining 6 electrons or losing 2 electrons? Alright, losing 2 electrons would be easier. Alright, and that is what magnesium atom undergoes when it becomes an ion. It will lose 2 electrons. So the electronic configuration of the magnesium ion would be 2,8. Please take note the difference between the magnesium atom and the magnesium ion. When we talk about the atom, we are talking about the original number, in this case 12. And when we talk about ions, okay, we have to decide whether it has lost or gained electrons. So since it has lost 2 electrons, okay, the magnesium ion will be represented by Mg2+. Next, let's look at chlorine. Okay, the electronic configuration of the chlorine atom is 2,8,7. Now, to become a stable noble gas electronic configuration in its ion, chlorine can either gain 1 electron to get 2,8,8, or it can lose 7 electrons to get 2,8. Which one do you think is easier? I'm sure you know that gaining 1 electron will be easier. So in this case, the electronic configuration of the chloride ion is 2,8,8. Okay, and since it has gained 1 electron, okay, the symbol representing the chloride ion is Cl minus. Okay, we don't write -1, we just write Cl minus. Okay, something to take note. If the ion becomes negative, the name changes. So example, chlorine becomes chloride. Okay, and if you compare with magnesium above, it's a positive ion, so it maintains its name, magnesium atom, magnesium ion. But if it is a negative ion, in this case chlorine, chlorine atom becomes chloride ion. Alright, now I want you to take out your periodic table. Okay, you can find it given behind worksheet 6C. You may pause the video here to get out your periodic table, and we'll continue afterwards. Alright, let's zoom in to the top of the periodic table on the left side. Okay, so here we have group 1. Okay, as we have recapped just now, if it's in group 1, okay, the element will have 1 valence electron. Okay, so think about it. How will it form ions if it has only 1 valence electron? Right, that's right. It will lose 1 electron. And since it will lose 1 electron, the elements in group 1 will form ions with +1 charge. Alright, so please write this at the top of your periodic table. Okay, next, group 2. Group 2 elements will have 2 valence electrons. Once again, if it has 2 valence electrons, how will it form ions? Okay, it will also lose electrons in this case, but it will lose 2 electrons. And since they lose 2 electrons, elements in group 2 will form ions with +2 charge. So write this at the top of your periodic table. Alright, these notes at the side, okay, you may write it if you want to know more details, but for now, okay, the top part is the more important one. Okay, moving on to the other groups. Okay, next we have group 3 with 3 valence electrons. So to become an ion, okay, group 3 elements will lose 3 electrons, and as such they will form ions with +3 charge. Okay, I will skip group 4 for now, and I'll talk about group 7. Group 7 will have 7 valence electrons. Okay, think about it. If group 7 elements want to form ions, what will happen? Do they gain or lose electrons? Alright, they will gain 1 electron, okay, to get the octet configuration. So since they gain 1 electron, they will form ions with -1 charge. Group 6 with 6 valence electrons will then gain 2 electrons. And since they gain 2 electrons, they will form ions with -2 charge. And lastly, group 5 with 5 valence electrons, okay, to achieve an octet configuration, they will gain 3 electrons and will form ions with -3 charge. Alright, so please write all this at the top of the periodic table. Okay, this will help you when determining what are the charges of the ions for each group. Okay, since I skipped group 4 and group 0, okay, I've mentioned this in class before. For group 4, okay, do they gain or lose electrons to achieve an octet configuration? Okay, in this case, for you guys, okay, just learn that for group 4, they will share electrons. And lastly, group 0, okay, your noble gases, helium, neon, and argon. Okay, they don't form ions because they already have they already have fully filled valence shells. Alright, so please remember, okay, from group 1 to group 0, what are the charges of the ions that they will form? Okay, I summarize them here in this table. Okay, using those shortcuts, okay, I want you to answer the following questions. What is the formula of the sodium ion? What is the formula of the oxide ion? What is the formula of the barium ion? What is the formula of the bromide ion? And if an atom has a proton number of 9, what is the charge of its ion? And if an atom has a proton number of 13, what is the charge of its ion? Pause the video here and write your answers on a piece of paper. Then we'll check the answers after this. Alright, for question 1, what is the formula of the sodium ion? Okay, if you look at the periodic table, the sodium element is in group 1. So what charge will its ion form? Okay, it will form +1. So the formula of the sodium ion will be Na+. Okay, you don't write the 1, so it's just Na+. Okay, next, question 2. What is the formula of the oxide ion? Okay, if you try to find oxide on the periodic table, you can't find. Okay, but please remember, okay, there's a change in the name, oxide. So oxide comes from oxygen. So in this case, oxygen will form a -2 charge ion. So the formula for the ion would be O2-. Alright, next, barium. Okay, if you look carefully in the periodic table, you'll find barium in group 2. So it will form ions of 2+ charge, and the formula would be Ba2+. And lastly, bromide ion. If you try to find bromide in the periodic table, once again you cannot find, but as you can see, there's a name change. So it actually comes from bromine. So in this case, Br is in group 7, and it will gain 1 electron. Since it gains electron, it will form -1 charge, and you'll get Br-. Right, next, an atom has a proton number of 9. What is the charge of its ion? Okay, the charge of a proton number 9 element would be -1. And an atom with proton number 13, what is the charge of its ion? It will be +3. Okay, for question 5 and 6, okay, you can either find what the element is on the periodic table. Okay, if you look for proton number 9 in the periodic table, it will be fluorine. So fluorine will be in group 7 and therefore will have -1 charge. And 13 would be aluminium, which is in group 3, so it will be +3 charge. So that is one method. Okay, another method is to look at the electronic configuration. For 9, it will be 2, 7. So it will gain 1 electron to form the octet configuration and be -1 charge. For proton number 13, the electronic configuration would be 2, 8, 3. So to form a octet configuration, it would lose 3 electrons rather than gaining 5. So losing 3 would be +3. Right, so if you notice, okay, when I just talk about the charge, okay, the sign appears first. So in this case, -1 and +3. But when you write it in the formula form, the number appears first. As you can see in the oxide, O2 minus, then barium 2 plus. So when we are talking about the charge, okay, we will write the sign first, then the number. But when writing the formula, okay, you'll write the number first, then the charge. Okay, but honestly, for charges, if you write 1 minus or 3 plus, okay, it can be okay for me. All right, at least I want to understand that you know the concept. Okay. Right now we shall look at the table of common ions. Okay, these are the simple ions that usually comes out for in our compounds and in exam questions. Okay, so I've grouped them under positive ions and negative ions. Okay, you can download this file under the reference section of this lesson. Okay, so you can either refer to this table to answer the following questions, or you look at the periodic table. Okay, something to note, okay, in the exams, okay, or in any test, okay, this table will not be given. So I hope you would refer to the periodic table instead, and then remember the shortcuts, okay, on top of the periodic table, the +1, +2, +3, and so on. All right, so how do we determine the chemical formula of simple ionic compounds? Okay, in an ionic compound, the positive charges must equal the negative charges. Okay, in other words, the charges must balance out. Okay, so what do I mean? Okay, before that, let's draw a rough table to determine whether the charges balance out. So I have positive ions on the left side and negative ions on the right side. And we shall determine the total charge. And the charges must balance out. So example, in sodium chloride. Okay, I want to determine what is its formula. Okay, and if you look at the periodic table, sodium is in group 1. So it will be sodium plus, Na plus. And chloride comes from chlorine, which is in group 7. So that will be Cl minus. Okay, let's see. What is the total charge of the positive ions so far? I have +1. And for the negative ions, I have -1. Are the charges balanced? +1 and -1. Yes, the charges are balanced. So the chemical formula for sodium chloride is simply 1 Na and 1 Cl because they can balance each other out. So you write that out as NaCl. Okay, let's look at another example. Magnesium oxide. Okay, if you find magnesium in the periodic table, okay, it will form a 2 plus ion. And as you have learned, oxide comes from oxygen, and oxygen will form the oxide ion of O2 minus. What are the total charges so far? I have +2 and -2. So are these charges balanced? Yes. So we have 2 positive and 2 negative. Okay, they balance out. So we just need 1 magnesium and 1 oxygen. So it's simply MgO. Right, so far I've given you examples where the charges balanced out. Okay, let's look at another one. Sodium oxide. Okay, so we have seen Na plus and O2 minus. Okay, in this case, the positive total charge would be +1 and the total charge for the negative is -2. Okay, the charges are not balanced. Okay, I only have +1 charge for positive and -2 for the negative side. So I need more positive charge so that they balance out. So in this case, I can add one more sodium ion and I will get +2. Okay, and finally, this is balanced. As you can see, I have two Na ions contributing a total of +2 charge and one oxide ion contributing to -2 charge. So the charges are balanced. So I have two Na needed for one oxygen. So the chemical formula for sodium oxide is Na2O. Alright, I'll give you some time to understand this process. Okay, one more example. Aluminium fluoride. Okay, if you look at aluminium in the periodic table, it will be in group 3. So aluminium is 3 plus. And fluoride comes from fluorine, which is in group 7. So it's -1. So in this case, we have a total charge of +3 on the positive ion side and -1 on the negative ion side. Okay, so how do we balance? Okay, what can we add so that the charges balance? Should I add more positive ions or should I add more negative ions? All right, as you can see, obviously we need to add more negative ions so that the charges balance out. Okay, so how many do we need to add? Okay, if I just add one more, the charge will be -2. But if I add a second one to a total of 3 F minus ions, I will get a total charge of -3. And finally, it is balanced. So in aluminium fluoride, okay, I will need one aluminium 3 plus ions and three F minus ions. So one Al and F I need 3. So the formula will be AlF3. Okay, I give you some time to think about what I have just shared with you. Alright, so you have learned how to write the chemical formula of simple ionic compounds. But I will now show you an alternative method. Okay, this method, I will call it the cross method. Okay, for this method, there are two conditions that you need to know. First, if the charges balance out, you just need one each. Okay, example, sodium chloride. So for this method, we will have workings and then we will determine what is the chemical formula. So looking at sodium chloride, okay, we must find out what are the ions inside. Okay, and if you look at the periodic table or the table of the ions that I shared with you, sodium would be Na plus and chloride will be Cl minus. Since the charges balance out plus and minus, I just need one each. So I get NaCl. Similarly, for magnesium oxide, okay, let's do some workings. Magnesium would be 2 plus and oxide will be O2 minus. Right, since the charges balance out 2 plus and 2 minus, I just need one of each. So I get MgO. So the chemical formula for magnesium oxide is MgO. Alright, what if the charges don't balance out? Okay, if they don't balance out, we will do the cross method. And this method involves crossing the numbers and removing any charges. Okay, so what do I mean by that? Okay, let's look at sodium oxide. Okay, an example we've done before. So once again, workings and the chemical formula. We have Na plus and O2 minus. Okay, as you can see, plus and 2 minus, they don't balance up. So what do we do? Okay, we are going to do a cross. Right, but you look at Na plus, okay, I say on top, cross the numbers. But Na plus, there's no number to cross. So what do you do? Alright, if you think about it, okay, when I only have plus or I have minus, the number there is actually 1. So in this case, I am crossing 1 to the other side and 2 to the NA side. Okay, after I cross the numbers, I remove any charges. So the chemical formula will be Na2O1. Okay, but since we don't write 1, the chemical formula would simply be Na2O. Alright, so sodium oxide is Na2O. Okay, I'll show you again the cross method. Okay, the working. So if I have plus or minus without any numbers, okay, remember there is 1. So when I cross, okay, for Na plus and O2 minus, I get Na2O. Alright, one more example. Aluminium oxide. Okay, workings and chemical formula again. Alright, aluminium is Al3 plus and oxygen is O2 minus. So we are going to cross the numbers. So in this case, 3 goes to the O side and 2 goes to the aluminium side. And I remove the charges. So the chemical formula I will get is Al2O3. So aluminium oxide is Al2O3. Once again, this is the workings with the cross method. So I cross the numbers and I remove the charges. Please take note, after you cross, the numbers are written at the bottom. Okay, numbers at the top are for charges. Alright, so for formula writing, you can choose your own method. So example, sodium oxide. Okay, you can either do the balancing charges method, the first method which I shared, okay, where you consider the positive ions and the negative ions and whether the charges balance, or you can do the cross method, which is the second method I shared. Either way, you will still get the same answer, which is Na2O. Alright, with that, try the practice questions in the quiz below. Alright, and I'll see you guys next time. Take care.